This project attempts to reproduce the results in Richard Sutton's original paper on the TD lambda learning algorithm. Shown here is the 7-state MDP that we are trying to solve. The agent starts in state D and moves randomly to the left or right with equal probability in the non-terminal states until it reaches the terminal states A or G. The outcome of a random walk sequence is 0 if you end up at A and 1 if you end up at G. The goal is to compute the value function, or the weights as they are referred to in the paper, for all the non-terminal states. To learn the weights, the learning algorithm is provided with training data in the form of 100 training sets, with each training set containing 10 sequences. Shown here is the description of the TD lambda algorithm. The expression over here, it gives the weight update for an entire sequence, and the expression here gives the weight update for a single step in the sequence. Now, to evaluate the learning algorithms, 2 experiments are constructed. In experiment 1, the weights are updated only at the end of a training set. Also, each training set is presented repeatedly until the weights converge. For experiment 2, on the other hand, the weights are updated after each sequence and each training set is presented only once. Let us now look at the results. The results for figure 3 are compared for the current implementation on the left with those in the paper on the right. The results are very similar, although there is an offset of about 0.09. We notice that TD0 has the smallest error among all the lambda values. Shown here is a comparison of the results for figure 4. We notice that the general trends are the same, although the results do not match exactly for some of the lambda. Shown here are the results for figure 5. Again, the shape of the curves and the trends are the same, although there are small differences. Unlike experiment 1, we notice that the error is smallest for lambda around 0.2 to 0.3 instead of lambda equal to 0. Lastly, we look at some of the reasons for the differences between the results in the paper and the current implementation. We need to note that there are only 100 training sets with 10 sequences each, and the results are very sensitive to the training data, and the training data used in the paper is not known exactly, and this leads to the discrepancies between the paper and the current work. Thank you.